This video is the first video discussing some common applications of diodes. We're going to start with an application of a diode where you can protect components that are voltage polarity sensitive. Namely, ICs, integrated circuits, are voltage polarity sensitive, where the IC will have a connection, a pin, where you connect the positive side of a voltage source, and then it will have another pin that you connect the negative side of the voltage source. And if you switch those, if you connect the positive side of the voltage source to the pin where the negative voltage side is supposed to go, and you put the negative side of the voltage source to the pin where the positive voltage is supposed to go on the integrated circuit, well, you'll damage the IC. Okay, it'll actually start to overheat and eventually become defective, where it won't work. It won't perform the way it should. Also, some capacitors are sensitive to the voltage polarity across them. You can tell these capacitors because somewhere on its physical shape, okay, somewhere on the body of the capacitor, you'll see a plus, or sometimes it'll have the minus. And the plus and the minus indicate that this is the higher voltage end and this is the lower voltage end. So if you were to connect a capacitor like this backwards, okay, put the lower voltage end on the plus side of the capacitor and the higher voltage end on the minus side of the capacitor, well, given enough time, this capacitor is going to physically destruct. In fact, it will explode like a firecracker. So because we have these components, all ICs, okay, all integrated circuits are voltage polarity sensitive, and some capacitors, okay, so only the ones that are marked with the plus minus. If you don't see a plus minus on a capacitor, then it's not one of these types, and you can hook the voltage to the capacitor either way, and it's going to be fine. So if we look at this diagram here, okay, this circuit has some ICs and capacitors in it, and it's connected up to a voltage source through a diode. And you see this diode is going to provide voltage polarity protection. And the way it does it is, let's say that the polarity of this voltage source, as shown, is the correct polarity for the ICs and the capacitors that are within this circuit. Well, as we discussed earlier, this will be the forward bias case, because current for the source is going to want to flow from the positive side to the negative side, since this source is supplying power. So current wants to flow clockwise through this circuit to go from one end of the source to the other, and as it flows in that direction, it's going to go anode to cathode through the diode, which is the forward bias case. So see, current would flow like this. Ideally, this diode would act like a short, and this entire source voltage would be across this circuit with the voltage polarity sensitive components, and because the polarity of the source matches the polarity of the ICs and the voltage polarity sensitive capacitors, well, this circuit's going to work fine. But let's say that this diagram here represents some sort of electrical device that a customer has access to the battery, and the customer goes to change the battery, and then they install the battery backwards. Okay, so if the battery was installed backwards, well, the diode's going to stay the same orientation. Everything in the circuit's going to be the same. Now, we can represent this circuit as a resistance, an equivalent resistance that I have labeled R circuit, but you can just think of this as an REQ, like we did in our circuit theory. So as we know from previous discussion, a diode is basically a voltage controlled switch. So if I keep the orientation of the diode the same, and I switch the polarity of the source, right, I flip the source, well, now current's going to want to flow from the source from this end to this end, right, because it's going to try to flow from the positive side to the negative side. But to do that, the current would have to go against the arrow, would have to flow cathode to anode through the diode, which it's not going to allow, right? That's our reverse bias case, and the diode is going to prevent any current from flowing by ideally acting like an open. And by acting like an open, no current ever passes through this circuit, so therefore this source voltage never gets to or never gets across the circuit that has the voltage polarity sensitive components, and that's what saves those components from being physically harmed, right? Because see, if the diode wasn't there, if we just had a straight piece of wire here and the customer puts the battery in backwards, well, that incorrect polarity voltage would get across those ICs and those polarity sensitive capacitors, and those components would be physically harmed. The ICs would heat up, the capacitors would explode, and your circuit wouldn't work. So any type of electronic device that has a battery that is accessible by the consumer will have a diode like this between that battery and the circuit that has the ICs and the voltage polarity sensitive capacitors to perform this protection that we just talked about. Okay, the next few videos will be on another application of diodes called rectification.